Hello. Today I want to tell you a story that's very interesting to me, which is that when Charles Darwin published his Origin of Species in 1859, the world was, on average, a much more religious world than it is today. The world has become much more secular. And of course, his one book didn't have that much evidence. But within 10 or 15 years, the scientific debate over evolution was over. Darwin's book was victorious, and the international scientific community accepted that evolution was a fact by the 1870s. Now the question is, how could that have happened in a world that was so against evolution and so religiously conservative? Whereas today, where the world is relatively speaking much more secular, and we have billions of times more evidence, many people seem to think that evolution is controversial. These two things to me don't seem to make sense. But I think the history of how evolution came to be uncovered in the first place can clear this up. So of course, centuries ago, people believed that the earth and the animals and plants in it had been created by a supernatural deity, rather as is depicted in this illustration from Luther's Bible from 1530s. A century later, Archbishop Usher from Ireland tried to estimate the age of the earth by counting the number of generations of particular people named in the Bible. He came up with an age of about 6,000 years for the age of the earth. But of course, there are things in the earth called fossils. Fossils have always been known. They are not new. Even the ancient Greeks and Romans knew about fossils, and they explained them as the remains of the giants and monsters from their mythology. So here's an image of one such of these monsters. In more recent centuries, particularly in Europe, things like this were very common. This shell-like object, which we now know is related to a type of oyster, was explained as the devil's toenails. Apparently the devil has some pretty nasty problems with his toenails, but anyway, and needs a pedicure. But these were dropped in the millions all over the world. But this was a folklorish explanation. Similarly for these objects, these were believed to be lightning bolts that had hit the ground. When lightning strikes the ground, it makes one of these. These were called snake stones for the obvious reason that they look like a coiled up snake. There's just one problem with that explanation, of course, which is none of these snakes have heads. But some local craftsmen were able to fix that by carving some heads onto them. Here's another very common type. These were called tongue stones. I'm not sure why. They don't look much like a tongue to me. But anyway, it was tongue stones that first unlocked the secret of what fossils actually are. And it was this man, a Danish bishop named Steno, who first established that the reason these tongue stones look just like the teeth of sharks is that they are the teeth of sharks, only that they are fossilized. And that got him to think very seriously for the first time, how could an object, part of a dead animal, like a tooth, become embedded in the middle of a rock? I mean, shark's tooth was once in the sea. Well, he discovered various things about stratigraphy. That is, that in places in the earth where the rocks are sedimentary, they began as mud or silt and settled in a horizontal fashion at the bottom of a sea or a lake. And that any hard objects that fell in that mud would slowly be buried. And if more and more sediment accumulates on top, eventually those layers become compacted and they become shale or sandstones. But one of the important revelations of this work, of course, is that that means that layers settle sequentially on top of each other, which means that the lower layers are older and the upper layers are newer. And thus it was possible to start to unlock the mysteries of the history of the earth by examining the earth itself. 100 years later, the Scottish geologist Hutton was able to use such studies, like in this diagram here. He's describing something called an unconformity. The layers at the bottom also originally accumulated horizontally, but somewhere in the depths of time, they have become tilted up vertically. Then they had been raised up above the sea so that the top above them has eroded away from the erosion of being on the surface of the the land. Then, at some time after that, it had all gone down under the sea again, and new layers were deposited on top. He said that this sort of thing showed that the earth must be practically, from our perspective, eternal. It is unimaginably ancient. Well, what about the fossils? Well, it's one thing to say that a little oyster shell or a snake stone, well, if it really is the remains of a living thing, they could still be in the ocean somewhere. It's very deep, or maybe they live in a remote region that we haven't discovered. But fossils like this, you couldn't dismiss in the same way. This is the fossil of a mastodon, discovered around the beginning of the 19th century. And the great French comparative anatomist, Cuvier, is the person who established for the first time something that was up until then very objectionable. That is, that living things can go extinct. Now, those little shells, you could argue, well, they might still be alive, but you couldn't argue that about a gigantic elephant creature running around North America. Nobody, for centuries, had seen any of these giant things running around. They were not hiding behind a bush or a tree. They were extinct, and he also proved they were related to the living species of elephants. This species, called the Megatherium, big beast, was discovered in Brazil. Cuvier established once again, okay, this animal was the size of a car, but from its bones and teeth, he was able to prove that it was related to sloth, which live uniquely in South America, where this fossil was found. This also is just way too big to be hiding somewhere. They were extinct. So extinction became an accepted principle in science. Cuvier also conducted very extensive examinations of the Paris Basin with his colleague, and was able to prove that there had been many different eras in the Earth's history in this particular region. There had been different ecosystems with different plants and animals, which had been followed by some sort of flood or disaster. Then there had been another age with different plants and different animals, and that had been wiped away. And then another age. All of those species were different in each era, and once they vanished, they never appeared again. They went extinct. These images on the side there are some of his reconstructions of what these animals looked like. They were mammals, but they weren't like any mammals that were alive today. They were unknown types. Then these were found, gigantic ocean-living creatures. At first they were thought to be fish, but their bones and teeth demonstrated that they were in fact reptiles. The one at the top was they called it an ichthyosaur, fish lizard. They give all the best names away at the beginning. Big animal, right? Could have used that later, too bad. And the lower one was a plesiosaur. These were also obviously extinct. No fisherman had dragged up any of these. They also were found in deposits with these bizarre objects. They were scattered in the millions in the same rock layers as the ichthyosaurs. And indeed, with close examination, they were even found inside the fossilized bodies of the ichthyosaurs. And soon they figured out what they were. These are nothing less than fossil poo, or fossil feces, if you prefer. This is ichthyosaur poo. And what it showed was that ichthyosaurs were carnivores. Because when slicing open these coprolites, as they are called, they contained fish scales and the crunched up bones of smaller ichthyosaurs, which led some people to claim, well, they must have been carnivores. Not carnivores. Cannibals, yes. So this allowed people to start to reconstruct a very realistic idea of what this ancient world looked like. And this is the first depiction of the ancient Earth. You've all seen something like Jurassic Park, etc. Yes, very fancy with all those computer modeling. This is the first one, the first image of an ancient Earth. And there they are, ichthyosaurs, etc., munching each other, and presumably producing lots of coprolites. And shortly after that, the dinosaurs were discovered, the so-called extinct family with which we are most familiar of giant creatures. Well, all of this was put together by the 1830s to a picture that was something like this. The world was unbelievably ancient, and the fossils that had appeared in it had appeared in a sequential story of progress. That is to say that in the earliest rocks were the most primitive creatures, shells, mussels. Later there were fish. After that, the reptiles appeared, and after that, the mammals appeared. This was universally accepted by all these men of science, long before Darwin or evolution were on the scene, because this was not evolution for them. This was just simply the history of the Earth. And these were all religious men, as you can see from the Reverend William Buckland, whose book we're looking at. This is a close-up of the same diagram, just to show you that nowhere in this history of the Earth was any human remains ever found. All of human history is composed of that tiny little white layer of scum at the top. So there was no doubt at all that these ancient worlds existed before the appearance of human beings. And so this is the way these pre-Darwinians depicted the history of life on Earth. It was a story of progressive change over time. Presumably they thought it was a series of new creations, one era after another. This is another one. You see the most ancient Earth that's at the bottom, and you come up towards the age of mammals. Then, of course, there are all the animals that were being found alive in the world today. The diversity of living things was mind-boggling. It was far beyond what had been expected centuries before. And so this became a very fashionable subject to study and try to figure out what was going on with all of these living things. And they began to categorize them in ways like this, which to our modern eyes looks like an evolutionary tree. But this is not. This is simply a diagram arranging different kinds of mollusks according to groups. It's a bit like, say, mammals. You have dogs, cats, mice. Those are all different groups, but they're underneath one group, the mammals. And then, of course, we meet Charles Darwin. Recent graduate of the University of Cambridge. He had the opportunity to travel around the world on a government ship, the Beagle, as a naturalist. He made some amazing discoveries, including his own fossil animals. This one, the Glyptodon on the top, was an extinct giant mammal, also almost as big as a car, found in South America. And it struck him immediately that this mammal, it's not a dinosaur, this mammal with bony armor plating on its back was strikingly similar to the only other mammal in the world with bony armor on its back, the armadillo, which lives in the same place. Similarly, he discovered this one called the Macrauchenia patagonica, the big neck of Patagonia, which he was told, it later turned out to be incorrect, that it was a giant extinct llama. And the same thing was true for Australia. They found giant extinct kangaroos, killer kangaroos. Their fossils were found in caves. Again, the same kind of creature from the ancient past as in the present. Of course, most famously, Darwin went to the Galapagos Islands, and he saw some pretty little birds. What was interesting is that he noticed there seemed to be a different type of bird on different islands. Why should that be? Darwin, as a geologist, knew that these islands had erupted as volcanoes out of the ocean. They were sterile and naked and dead. Species had colonized them. As an expert from South America, he knew these birds were obviously South American sort of birds, but they were different species. It was obvious in those days that a local variety could emerge. You could take, say, cattle and horses from Europe, take them to America. After 100 years or so, they were a bit different. That wasn't evolution. That was just the formation of a local variety. They were sure that there was some sort of limit beyond which things couldn't change. Well, what about those in the Galapagos? There they are, 600 miles away from South America. They obviously came from South America. But did each species independently arrive at its own island and no other? Of course not. It's much more likely that they arrived somehow to the Galapagos and then diverged. And Darwin figured they must have evolved. When he got home, he took a little bit of time off from theorizing to get married. And the consummate naturalist that he was, these are his notes on whether or not to get married. Pros and cons, marry, not marry. I don't have time to read all of them to you, but I will just point out that on the positive side here, a constant companion, a friend in old age, one to feel interest in one, an object to be beloved and played with. Well, but then he writes above that line, better than a dog anyhow. Okay, he was not a romantic, he was a scientist. And around the same time, he drew this notebook sketch, which was the first time that a real evolutionary family tree was drawn to represent how living things can descend from common ancestors and diverge into many family groups. So this is the same diagram with the dogs. I've photoshopped the dogs onto Darwin's diagram. To explain, from the common ancestor of the dog groups, you have all of these possible descendants, with lots of them that have gone extinct. So how to explain that some groups are very similar, but others are rather different? It's from differential relatedness. Similarly with his idea of natural selection, his most famous idea, but I won't go into that so much because actually it had very little to do with the acceptance of his idea, which was that all individuals vary, some survive and some die. But the other evidence was equally powerful for Darwin's theory, such as embryology. The embryos of animals do not start out as little tiny adults that just get bigger and are born. Embryos go through a weird set of stages and shapes which all resemble each other despite them being completely different adult organisms. So in this diagram, a turtle, a chicken, a dog, and a human, their embryos all look remarkably similar at the same stage. Why? Because they are related by common ancestors. Similarly with homologies, the same structures in the bones of all of these different animals. There was no other explanation, and there still isn't, but that they share common ancestry. Why should the wing of a bat or the paddle of a whale have the same identical bone structure? Then there are vestigial organs. Why should the manatee have fingernails on its flippers? Or whales that are born with no teeth when their embryos have teeth in their jaws? Or birds that are flightless that have wings? Well, this young man, Alfred Russel Wallace, came along and the identical theory to Darwin and prompted him into print after 20 years of working on it, and he published The Origin of Species in 1859. Shortly after that, even more evidence arrived. A new fossil, this one, the Archaeopteryx, still one of the most famous fossils in the world, halfway between the dinosaurs and the birds. And the shocking, because it is a dinosaur skeleton, but it has feathers. And this is the shocking point. You've always been told that the dinosaurs are extinct. That is not true. One family of the dinosaurs never went extinct, and they are called birds. So the next time you have chicken, remember, you are eating dinosaur. So, Darwin's theory is often called the survival of the fittest as a sort of shorthand. Well, it's not a very good shorthand. I think probably a better shorthand is it's often survival of the luckiest. Thank you very much.